Hello. In this lesson, we will learn one of the most important Git skills, working with branches, merging changes, and resolving merge conflict. If you are learning Git, GitHub, DevOps, or you simply want to work with code properly, you need to understand what a branch is, why branches are useful, how Git branch, Git switch, and merge work, and what to do if a merge conflict appears. Today, we will continue working in the same repository that we used in the previous lesson. We will create a separate branch for the task, make a change, merge this branch back into main, and then we will intentionally create a simple conflict and resolve it manually. After this lesson, you will understand the basic workflow, future branch, then merge into main. A branch in Git is a separate line of work in a project. We have the main version of the project. Usually this branch is called main. It contains the main code that we consider stable. But very often we need to change something, add a new feature, fix a configuration, update the readme file or try some idea. If we do everything directly in main, we can accidentally break the main version of the project. That is why in Git we create a separate branch. In this branch we can safely work on a specific task. When task is ready, we add the changes back into main. This process is called merge. The main idea is simple. Main is the main branch, and a separate branch is a safe place to work on a task. It may seem that branches are needed only in big teams, but actually, branches are useful even in a small project where only one person is working. For example, we have a training Git project. It already has a readme file and appconf file. Let's say we want to update the readme file. This is a small change, but it is still better to do it in separate branch. Why? Because a branch separates on one task from the main version of the project. If everything is good, we will merge the changes into main. If the idea is bad, we simply will not add this branch to main. This approach helps your work in a clean and understandable way. One task, one separate branch. Before working with branches, let's check the state of the repository. It is important to start from a clean state, so we do not have any uncommitted changes. Before switching branches and merging branches, it is a good habit to check git status. For this, we use a git status command. Git shows that we are on the main branch and the working directory is clean. This means there are no uncommitted changes right now. Now we can safely create a new branch for the task. The first command you need to know for working with branches is git branch. It shows the list of branches in the repository. The asterisk next to the branch name shows which branch we are currently on. Git branch. Right now we have only one branch, main. The asterisk before main means that we are currently on this branch, so at the moment they only have the main line of work. Now let's create a separate branch for small tasks. To switch between branches, we use the git switch command. But right now, we only have main. So first we will create a new branch and switch to it immediately. For this, we use the git switch command with the -c flag. The -c flag means create a new branch and switch to it. You may also see the older command check git checkout -b branch name. But in this lesson we will use the modern git switch -c command. Git switch -c read update git branch. Now we have two branches. Main is the main branch. Readme update is a separate branch for our task. The asterisk is now next to readme update. This means that all changes we make now will happen in this branch. Now imagine that our task is to slightly update the readme file. We are already in a separate branch, so we can safely change the file. Let's open readme with nano and add one new line. Readme. Yeah. This project is also used to learn git branches. Ctrl+X save. Yes. Let's check. Readme. Yes. And it's done. Yes. Git shows that we are on the readme update branch and the readme file was changed. Now let's save this change in commit. Git add readme and comment. Git commit -m update all branches. Let's see. Yes, all done. Now the change is saved in the history of this branch. It is important to understand we made the comment not in main, but in the separate branch readme update. Now let's switch back to main and see that is there. Git switch and check file. Notice the main doesn't have the line we added in the separate branch yet. This is the main idea of branches. We can work separately and the main branch stays unchanged until we decide to merge the changes. Now our task is ready. We changed readme in a separate branch and made a commit. Now we need to add this change back into main. For this, we use the git merge command. Merge means combining one branch with another. There is one very important point. Before running merge, you need to be in the branch where you want to add the changes. We want to add the change into main, so we need to be on the main branch. In other words, the current branch receives the changes. We are standing on main and we pull changes from readme update into main. Let's check this. Git branch and git start. The asterisk is next to main. This means we are currently on main. Git status also shows that the working tree is clean. This is a good habit before merging branches. Now let's merge the readme update branch. Git merge readme update. Check. Now the change from the separate branch is in main. In this case, Git used a fast forward merge. This means Git simply moved main forward to the commit from readme update. There was no conflict and no special merge commit here. We have completed the basic workflow. Create a branch, made a change, made a commit, switch back to main and run merge. This is one of the most common workflows in Git. Now that the readme update branch is merged, we can delete it locally. Branch -d and name. We deleted only the branch name. We did not delete the commit. The change is already in main, so this branch is no longer needed. Now let's talk about an important part: conflicts. A conflict appears when Git cannot automatically understand which change should be kept. For example, in one branch we changed one line in one way, and in another branch we changed the same line in a different way. In this situation, Git stops the merge and asks a person to resolve the conflict manually. This is normal. A conflict is not a disaster, and it is not a Git error. Git simply says, I see two different changes in the same place, and I cannot choose for you. Now we will intentionally create a simple conflict in the app file. Right now, the file has the line port equals 9090. We will change this line differently in two branches. This way, Git will get a conflict and we will be able to see what it looks like. First, let's create a new branch for the configuration change. In this branch, we will change the port to 3000 and make to commit. Then we will return to main, change the same line to 8080 and also make a commit. After that, we will try to run merge. Git will see that the same line was changed differently and will show a conflict. Git switch -c change port. Nano. Let's change let's check. Yes, port changed. It and git commit. Change port 3000 in branch. Okay, we're done. Now in the change port branch, the port was changed to 3000. Now let's return to main and change the same line in a different way. Git switch main nano up, and here will be 8080. Let's check. Yes. Git commit change port. Now we have two different versions on the same line. In the main branch, the port become 8080. In the change port branch, the port become 3000. Now let's try to merge change port into main. But before merging, let's check where we are and make sure the working tree is clean. Git branch and status. We are currently on main. This is important because the current branch receives the changes. So now we will bring changes from change port into main. The working tree is clean, so it is safe to start the merge. Git merge change port. Git says that the automatic merge failed. A conflict appeared in the app.conf file. Now we need to open the file and resolve the conflict manually. Let's see what the conflict looks like inside the file. Open the file. Git added special lines. The line with the less than signs shows the beginning of the conflict. Head points to the current branch. In our case, it points to main. Next, we see the version from main, port equals 8080. Then there is a line with equals signs. This is a separator. Below it, we see the version from the change port branch, port equals 3000. The line with the greater than signs shows the end of conflict. Our task is to remove the special Git lines and leave the final version of the file. In real work, you choose the correct version or combine the changes. For simplicity, now we will keep port 8080. We delete everything. This will be nice. Cut and git status. Yes. We already fixed the file manually, but Git doesn't know yet that the conflict is resolved. To tell Git that the file is ready, we need to run git add. During a merge conflict, git add doesn't just stage the file. It also tells Git that the conflict in this file is resolved. Git add app.conf. And let's check. And let's do commit. So conflict. Now the conflict is resolved and the merge is complete. We manually choose the final version of the file, edit the fixed file with git add, and made a commit. The basic process of resolving a conflict looks like this. First, open the file, then remove the conflict markers, leave the correct text, run git add, and finish the merge commit. Now that the change port branch has been merged, we can delete it locally. Git branch -d and yes. Again, we deleted only the branch name. We did not delete the commits. The final result is already merged in domain. Let's quickly review the workflow. Usually, the process looks like this. First, we're in main. Then we check the status to make sure we do not have uncommitted changes. Then we create a separate branch for a task. We work in this branch. We make a commit. We return to main. We check status again before merging. Then we merge this branch into main. Remember, the current branch receives the changes. So if we are on main and run git merge feature branch, we bring changes from the feature branch into main. If there is no conflict, git combines the changes automatically. If there is a conflict, we open the file, resolve the conflict manually, and the fixed file with git add, and finish the merge commit. After the branch is merged, we can delete the local branch with git branch -d. This is a basic workflow that is used all the time in training projects, in small projects, and in real DevOps practice. Now let's show the history as a graph. Log one line graph all and decorate. Oof. This command shows the commit history as a simple graph. The -- graph option shows the branch structure. The -- all option shows all branches. The -- decorate option shows branch names, for example, main. Your output may look a little different, and that is normal. The important thing is that we can see the commit history and how the branches were merged. Right now, we do not need to deeply analyze the graph. The main idea is this: branches allow us to work separately, and merge allows us to bring ready change back into the main. In this lesson, we learned what a branch is in Git and why it is useful even in a small project. We used git branch, git switch, created a separate feature branch, made a change and merged it back into main. We also intentionally created a simply merge conflict in the app file and resolved it manually with nano. We learned that before switching branches or merging, it is a good habit to check git status. We also learned that during merge, the current branch receives the changes, and after a branch is merged, we can delete the local branch with git branch -d. The main idea is this: you do not need to make all changes directly in main. It is much more convenient and safer to create a separate branch for a task, make changes there, and then merge them back into main. In the next lesson, we will move to GitHub. We will talk about a remote repository and the typical workflow, local repository, GitHub, pushing changes and pulling changes back. Thank you for watching and see you in the next lessons.